Hello friends, welcome back. And in this lesson, I want to talk more about Databricks components. Although I'm already discussing about these components during the demo, but from certification point of view, these are important. And I want to make sure that I spend a little bit more time in explaining these components in more detail. So let's start. Right now, I am inside the Azure Databricks portal. And on the left hand side, we have clusters. And if I click on clusters, I can see here that we have two options, interactive cluster and automated cluster. So let's first discuss about the interactive cluster. Interactive cluster, as the name suggests, it is used when we interact with the notebook. So for example, as you know, we can create a notebook in the Databricks, and we can run queries in notebook. We can fetch the data or we can process the data. And to support all these queries, we need some kind of cluster in the background. And interactive cluster we use for that purpose. So we manually create this cluster, and then we process data using notebook, and then we manually terminate this cluster. I mean, there is an option to auto terminate, but the point is cluster will not terminate by itself after the job. Now there is another option here, which is automated cluster. Automated cluster we do not create manually. Even if you see here, we do not have any option to create cluster. We have option to create cluster for interactive cluster, but not for automated cluster. Now, so why we use automated cluster? See, if we create a job and that job is scheduled to run at a particular time, and to run that job we need a cluster. So when job will start, this cluster will be created automatically, and when job will complete, this cluster will also be terminated automatically. We do not manually create or terminate these kind of clusters. We have interactive cluster and we have job cluster. And as I said, interactive clusters can be used by multiple users because multiple users can work at the same time on notebook, and they use these kind of clusters to analyze and process the data through notebook. And then we have the job clusters, and these clusters are created and terminated for running automated jobs. Now let's discuss a little bit more about these two kinds of clusters. So as we discussed that interactive cluster are used to interactively analyze the data through notebook, and it is manually created by user. And there's also an option to create these clusters through cluster API. Similarly, either we can terminate this cluster through cluster API, or we can manually terminate this cluster. That means if we forget to manually terminate this cluster, it will keep charging us. So that means no matter if you are using it or not using it, if it is running, it will cost you. Now this is not just about Databricks cluster, but I want to say in general also in Azure, you want to make sure that if you're not using those services, you should try to stop or terminate those services which is charging. For example, in data warehouse, it happens almost to everyone that they forget to stop the service of data warehouse, or Azure Synapse I should say, and then on the background it keeps charging you. But thankfully here we have option to auto terminate the Databricks if it is inactive. So that means if my server is idle for some time, let's say for 30 minutes or 1 hour, if there is no activity for my cluster, then that cluster can be terminated automatically. And this is a very good feature. It saves a lot of money. If you forget to terminate this cluster, it can terminate automatically, and this is a big money saver. And next is low execution time. Because these clusters are already running, every time you run the query, you do not have to create this cluster or terminate this cluster. We can manually create this once, and then we can do all our analysis. Whatever queries we want to run, we can run all those queries, and then in the end we can terminate this cluster. So when we are running those queries at that time, we do not create these cluster for every query. In that sense, cluster is already available, and that's why execution time is low in interactive cluster. And these cluster can be scaled automatically as the workload increase, as the demand increase, and comparatively it is less costly than the job cluster. And then we have the job cluster, and as you know by now that job cluster is used to run automated jobs, and these jobs when start they create these clusters, and at the end these jobs terminate these clusters. Now obviously these clusters are terminated in the end by the job, so we do not require separate auto terminate functionality, and so we do not have that. Now another interesting point here is it provides a high throughput. Now what does that mean? In the job cluster, there is definitely an overhead for the job to create a cluster every time job start. But once the cluster is available, it is fully dedicated for that particular job. In case of interactive cluster, if you remember, multiple users can work on the same cluster. So multiple queries can be run on the same cluster. So these clusters are not dedicated, but this cluster is specifically created for that job, and it is fully dedicated, and that's why it provides the high throughput. And in case while running the job, if for some reason suddenly the workload increase, these clusters can also be auto scale, and these clusters are much cheaper than the interactive cluster. So for certification point of view, it is important we understand the difference between these two clusters very well. Alright, so let's move forward. So let me go ahead and create an interactive cluster. So let me click on create cluster, and now the next important setting is to choose cluster mode, and we have two options here, standard and high concurrency. So let's look at the difference between these two in more detail now. Alright, so first one we have is the standard mode, and this is generally preferred for single user. Now why single user? Because this does not provide a fault isolation. What does that mean? So if there are multiple users, and if one user get some issues with the code and his code start failing, then it may influence the other users also. And also it does not have task preemption. That means one user may consume all the resources, and other user at the same time may not get even the minimum resources required to run his job. So there is no proper resource allocation mechanism also available. And that's why I would say that each user should require or create separate cluster in the standard mode. And but the good thing about is it support all the languages: Scala, Python, SQL, R, or Java. Now on the other hand, we have high concurrency mode, or it is also called Databricks serverless cluster. And this is especially designed for multiple users because it has a fault isolation. That means failing the code of one user will not influence the other users. And at the same time, it is not like one user is taking all the resources. Even if one user consume resource because of heavy workload, others will also get some reasonable share of resources, and that will allow their jobs to be done on time. And that's why multiple users can work on the same time, and this helps to optimize the cluster efficiency. And this definitely saves also a lot of cost, because this cluster can be used by multiple users at the same time, and we take a maximum output of this cluster. But this cluster does not support all the languages, especially the Scala. If you see, this cluster does not support the Scala, and Java also is not supported by this server. All right, so I am back to my portal, And after choosing cluster mode, for example, I choose a standard or high concurrency, whatever we choose, the next important setting for the cluster is to choose worker type node or driver type node. So worker type nodes are the nodes who actually perform the task. These are the nodes which actually take or do the task of data processing. And since the data in the Spark is processed in parallel, the more worker nodes we have, the faster will be processing. And that's why you see that we have option here to choose a number of worker nodes, minimum and maximum. And the driver type node is actually node which receive the task and then distribute the task to the worker nodes and then coordinate the execution. So obviously we do not need more than one driver type node, and that's why we do not have to choose a number of driver types. So we will always have one driver type node, and we can choose to have multiple worker types node. And here you can see that we have option to enable auto scaling, and that's why we have minimum and maximum. So if we disable enable auto scaling, we can choose the fixed number of worker nodes here, and or we can choose to have enable auto scaling. That means it will start with 2, and depending on the workload, if there's a more workload, it will keep adding the worker nodes, more and more worker nodes, until it reach to the maximum worker node, which is 8. And the last thing is of course about auto termination setting here. Terminate after these many minutes of inactivity. If my cluster is idle for, let's say, 30 minutes, my cluster will terminate automatically. And believe me, it can be a lifesaver. It happened to me, and it happens to all of us sometimes. You forget to terminate the cluster, and these kind of settings saves your life, because if cluster does not terminate, and for some reason you do not come back here to see what's going on, and you suddenly get the month bill, bill at the end of the month of a couple of hundreds of dollars or thousands of dollars, that can be very painful. So I think we should always choose this setting to terminate clusters if there is an inactivity. So I hope by now we have a good understanding of clusters, and this topic is certainly very important from certification point of view. That's why I took so much time to go into detail of all of these settings. Thank you. But in general, for overall understanding of Azure Databricks. So right now I'm inside the Azure Databricks portal, and we have a workspace. When we create Azure Databricks instance, we choose to have a workspace, and I have this, my workspace ID, workspace 108. So we'll discuss a little bit more about this. We will discuss about the database management, databases and tables we create inside the Databricks. We'll discuss about this, and we will also discuss about the jobs here, like how we can immediately run the job manually, or how we can schedule the job and things like that. And we will also discuss about the notebook here. We can create different notebooks within workspace. So we will discuss about more features and capabilities of notebook. So let's start with the workspace. Workspace is, as you know, is a key isolation unit in Databricks. Each workspace and its resources are, let me open my pointer here. So I was saying that each workspace and its resources are completely separate from other workspace. So even if they are in same subscription and multiple users are creating different workspace, they all will be isolated in themselves. They will not interfere or consume resources of each other. So when you create an instance of an Azure Databricks service, a single workspace is created, and a unique workspace ID is used to identify this created workspace. And a part of this workspace, a number of resources are also deployed in the control plane as well as in the data plane. So as you have seen in previous module, the data plane components are part of our own subscription. And these resources are locked and cannot be changed later. So once you start the workspace, you can organize various assets and folders like your notebooks or libraries or your dashboard. In fact, you can also organize your clusters, your data or tables also. And you can even define the fine-grained access control for all of these assets. Now let's discuss about the notebook here. Now notebook is the place where you are actually going to write your code, and you can do that in any language supported by Spark. You can write code in Scala or Python or SQL or R or Java. And the major part of these notebook is that you can write code in several languages in a single notebook. So you can extract data using Scala, and maybe you can write transformation using logic in SQL within the same notebook. So let me go back to Portal and show you how it works. So I'm back to my Portal now, and here if you see, if I create a notebook here, I can say test demo, and here I need to define in which language I want my notebook is. So I can choose to be a Python, and then I can create. Now once I have notebook here, even though I created this notebook for Python, but in between that, let's say if I want to run some code in SQL, I can mention SQL here. I can enter. I do not have a cluster here, so I cannot run this now. So I can just write this %SQL, and I can execute this, and then I can start writing code in SQL. Similarly, I can write %R, and then I can start writing code in R. So this is so amazing and wonderful to see that within the same notebook, I can run code using different languages. The next point is that from the notebook, I can also invoke other notebook, and I can also pass the data into this other notebook. And this can help to build end-to-end workflows. And you can also run queries on notebook using an interactive cluster, or you can run complete notebook with the job using the job. We discussed about both these cluster in previous lesson. And then these notebooks also support integrated visualization. So you have tabular data, and you can instantly visualize it using the charts and the graph from the notebook itself. And you can use the same data sets to create a dashboard easily. And finally, as we talked about earlier, it encourages collaboration with multiple users. And as we discussed, that multiple users can work on the same notebook using different languages, in fact, and they can edit and they can put their comments, they can make changes within the same notebook. So it encourages collaboration. Now, next I want to talk about the jobs. Jobs allows you to run a notebook, or if you have an external jar file that you would like to run on a Spark cluster, you can do that using a job. So job can start immediately, or it can also be scheduled on particular time or particular frequency. And then these jobs can run on clusters, and job clusters are created and terminated with the job. But if you have interactive cluster running, you can run these jobs on them as well. We discussed this in detail in our clusters lesson. And then each job can also have a different configuration of the cluster that it can run on. It's not necessary that we have to choose the same configuration for every job. And this actually allows a smaller cluster to be used for smaller jobs and larger clusters for larger jobs. And eventually you can completely track these jobs You can retry on failures and set up notification alerts, and you can configure it in a different ways to make it more efficient and helpful to monitor and track. Now, next is the libraries. So you will also like to use third-party libraries in your design, and you can install these libraries on the cluster. They can be used in any Spark supported language. You can connect to these libraries in your notebook once installed on the cluster. The libraries can be scoped to the cluster level, which means that it exists only in the cluster context. So you can install and expand the library at the notebook level also. And finally, we have the database and tables. And if you're coming from a relational database background, you are really excited to see that you can create database and tables inside these Databricks. But be very careful though. It's very different from relational database. The Databricks table is a collection of structured data. This means that the table has a structure, columns and data types, and in well organized way. This table is equivalent to a data frame because the data frame has a structure as well. This means any operation you can perform on data frame, you can do the same thing on the table. A table is guaranteed using a file that is present in the database. So in effect, this is just a representation of the underlying file where you know the schema. And any modifications to the file would also affect the row. And if the table is available, you can query it and you can write to it. And this is equivalent to working on a file. But you might be thinking that if it's just a file representation, then what's the use of the database and table? Well, the advantage is that you can keep multiple files together where the schema is defined. And this makes it much easier to work with these tables. All right, so the first option we have is the Ganglia monitoring system. And this is probably the only monitoring tool we have which is inbuilt with Databricks, and this collect data in every 15 minutes. And there's an also option to look at the snapshot of live data. So let's jump into the portal and I can show you where we can look into this Ganglia monitoring system. All right, so I'm into my Azure Databricks portal now. And on the left hand side, if you see, I have clusters here. And if I click on clusters, I have this one interactive cluster. So let me click on that. And here you can see the metrics. And if I click here, you can see the live metrics by Ganglia UI. And if I click on this, I have this tool where I have a couple of graphs I can look at. For example, how the cluster load in the last 1 hour, or memory last 1 hour, or network in last 1 hour, or CPU in last 1 hour. You can see the total number of CPUs we have, the host stuff we have, and you can choose the different time granularity here. You have different graphs here. You can go to the views here, or I do not have a lot of data here, but basically you can choose different reports and live dashboard, and different graph here. So this is probably the only tool we have right now which is inbuilt in Databricks and which we can take advantage of. I know this is not as good as like metrics and the alerts we have for other services, but this is what we have. And other option you have is, for example, you can go to driver log here, and here you can see that we have 3 kinds of log. You have standard output here, you have standard error, and log4j output. And you can look at these logs sometime in case you're facing some issues or you want to troubleshoot further. And you can also download these files from here, standard output, standard error, or log4j active.log. And other option you have to look at the event log here. So if I go to the event log, I have some of these events on which I can filter and can figure out what's going on with my Databricks, and some of them can be important. For example, you can look at this Spark exception. This can be important. Or maybe you can look at, let's say, driver health. Basically, the point is, you have few events here on which you can filter down and can troubleshoot your Databricks. All right, so I'm back to my slides, and the next monitoring option you have is the Azure Monitor. But let me tell you, this is not as easy as it is generally with other services, because there is no native support for Databricks. You cannot just directly go to Azure Monitor and can filter for the graphs, and you have to take some steps to actually use Azure Monitor here. First of all, you have to download and install the drop wizard metrics library, and then you have to build a jar file, and this is the name of the jar file, which is available at GitHub. And then you have to create the gauges and counters in your application code, and basically you can start sending the log data into Azure Monitor. And you can also use the log4j appender library, and you can create log4j properties configuration file. Honestly speaking, I have not done this myself also, but this is the steps we are supposed to take if we want to monitor the Databricks with Azure Monitor. And then the third option we have is Grafana. Now, this is an open source visualization platform that allows you to see the chart in more of a fashion what you would be expecting for a Databricks, and this is some of the sample charts I'm showing you below. But the point is, in order to use Grafana also, you have to follow some of the steps. First, you have to install the drop wizard metrics library, and then you have to configure Azure Log Analytics workspace, and then finally you have to deploy and configure Grafana. And then you will be able to see some of graphs like this. For example, in this graph you can see the cluster throughput, and in this graph you can see the job latency. If you are preparing for certification, I just want you to make sure that if you see Grafana somewhere in the option or in the question, you know that we are talking about Databricks. So basically all you have to do is to just remember these names here, that you can use the Ganglia monitoring system, and that's what is to monitor the cluster. Or you can use the Azure Monitor, and Azure Monitor described as a best solution among all of them. But in order to do that, you have to install this drop wizard metrics library, and again all you are getting from that is you're getting some log functionality. And then the last one is, as I said, the Grafana dashboard is an open source. This is the third party, and again there's some configuration issues that you need to work through in order to get sort of dashboard like this here. So I just want to make sure that you remember these names if you're preparing for a certification. Thank you. So what is Data Factory? Now, in simple terms,